page. This next one has 3 points. I can tell because it says 34 through 36. That's 34, 35, 36 points. I have to write a chemical equation. I have to include energy. I don't have to know how much energy, just if it's going in or whether it's going out. And with that, I'll determine whether or not it's exothermic or endothermic. So then we're also going to draw some standard potential energy curve. So what does this look like? Butane gas, C4H10, is burned with air. You're supposed to know that that's the oxygen in the air that burns. When you burn, it's combustion. You have to have oxygen. It's going to tell you that the products are carbon dioxide plus water. This does not say we have to balance it. It doesn't say the balanced chemical equation, so really not that necessary, though if I wanted to, I'd need a 4 there because there's 4 carbons there. I'd need a 5 there because there's 10 hydrogens there. I now have never mind. Now I now have 13 oxygens on the right-hand side, so I'd need a 6.5, but I can't put a 6.5, so I'm going to double everything. Double that. Double that. Double that. Now I have 10 plus 8. 10 plus 16 is 26 oxygens, so I need a 13 there, but it didn't say to balance it. Okay. When we burn something, energy comes out. We don't have to put the energy in. It's chock full of energy, and energy comes out. It exits. It goes into the room. Therefore, it is exothermic. Now for the energy flow. Got to ask myself some questions from the beginning before we burn it to the end when it's all cooled off because the fire's all done and it's all back to temperature. What happens? We're going to start with some butane. That stuff's usually kind of cold. Not much thermal energy. If you ever touch something like liquid like gasoline or alcohol, it feels kind of cold. But when we burn it, there's going to be all kinds of heat given off. But after another hour or so, once it's all done, they will cool back down to the exact same temperature. So the thermal's going to go from low to high as it's burning to low. Consider it's a fuel, and fuels are chock full of chemical energy. I don't know, 4 bars, 3 bars. I'm going to say 4 bars. What's happening to that is that changes into, that chemical energy changes into thermal energy. So I'm going to have a E chemical energy changing in. Internally, it's changing into it, and heat's given off. That means that we're going to have all kinds of less chemical energy. When we're all done, the products aren't going to have much energy. But then, so when we're all done, there's not going to be much chemical energy. It's all used up, but then it cools back down. Where does that heat go? Well, if we have 4 bars here, but the temperature is only 1 bar here, thermal, we must have had 1, 2, 3 bars leaving the system, which is that chemical. Next ones are identifying type of reaction. You don't need to balance these. The first one looks double complicated plus double complicated gives you double complicated and double complicated. That must be a double replacement reaction. This is where the dance partners trade places. Double replacement. Calcium's now dancing with sulfate. Aluminum's now dancing with hydroxide. This next one is a single element that kicks out the iron, and a single element of iron is left over, and it trades dance partners. That's a single replacement. It's evidenced because it doesn't look all double complicated. There is an element on each side. This next one, when you have lots of C's, H's, and O's, you usually look to see if it is a combustion. Combustion is when something burns with oxygen. The products are either carbon dioxide and water or carbon monoxide. This one happens to be carbon dioxide. This is a complete combustion. If you only have one thing you start with and it breaks up into 2 or 3 or 4, but in this case it's one thing breaking up into 2, one thing breaking up is a decomposition. If you only have one reactant, that's all that can happen, decomposition. Another CH&O one, only this time one of our products is carbon monoxide. We just have to remember that that's called an incomplete combustion. Carbon monoxide is a dangerous, poisonous gas. Finally, the last one, if we have one product and only one product, we must have had simpler things adding together, combining. It's got two different names. It can either be called a synthesis or it can be called a combination.